Welcome to another Trig survival guide. Today we're going to verify a trig identity. We're looking at 1 plus tangent squared theta over 1 minus secant theta equals negative secant theta. So we know the first thing we should do when verifying a trig identity is decide which side we're going to work on. We can only manipulate one side in order to prove. So we usually like to choose the more complex side, the one that we feel we can make more substitutions, we can manipulate more. And in this case, I think that's the left-hand side. We have several terms and it's a lot easier to combine multiple terms to equal 1 rather than trying to split apart and build up from the other side. So we'll work on the left side. And now let's strategize here. We mentioned earlier that we have two terms, they're connected by addition. And so a common denominator would be a great way to start our approach. We can combine and see then what we're working with. So let's go ahead and draw our vertical bar. That way we aren't tempted to work on that right-hand side. And we'll get our common denominator. So let's rewrite 1 as 1 minus secant theta over 1 minus secant theta. That's still 1, of course, because those common factors would cancel, but it's just rewritten. So now we can combine our terms. So in the numerator, we have 1 minus secant theta plus tangent squared theta all over 1 minus secant theta equal to, I'm going to abbreviate right side, RS. So now we have to be a little bit creative here because there's nothing that we can initially combine in the numerator. We should notice, however, that tangent squared is part of a Pythagorean identity that includes secant squared. So we know that 1 plus tangent squared is equal to secant squared. So we can rearrange that and have tangent squared equals secant squared theta minus 1. So we have tangent squared in our equation, in our numerator, and we could replace it so that now we would only have a secant term and a 1, or a negative 1. So we're replacing this tangent squared here, and I'll go ahead and rewrite. So we have 1 minus secant theta still, and we've replaced it with a positive secant squared theta minus 1, all still over that common denominator, equal to our right-hand side. This substitution now allows us to make some simplifications in our numerator. So of course, 1 minus 1, that cancels to 0. And we see that negative secant theta and secant squared theta have a common factor. So let's go ahead and pull out a negative secant theta and see what we have. So in the numerator, if we factor out a negative secant theta, of course, with the first term, we're left just with a 1. And the second term, we'd be left with a minus secant theta, all still over that common denominator. And that equals to the right-hand side. So now that we're in a factored form, we see that we have that common factor of 1 minus secant theta. When we cancel that out, we're left with what we actually want. We're left with negative secant theta equals negative secant theta. So we had to be a little bit more creative with this one. We kind of had to make a clever substitution or a very intentional substitution using that Pythagorean identity. So we got everything in terms of the function we wanted in terms of secant. So as you practice this more, you'll get better and better at seeing things and being creative in terms of how you could make a substitution to get where you want to go. I think that's one of the things that makes proving trig identities so interesting and such a neat topic. You get to have a little creativity. There are multiple solutions possible. And so it's just that chance to be creative that we don't always get. Be sure to check out the link in the video description. It'll show you a lot more worked out examples of verifying trig identities. So keep practicing. The more you do, the better you'll get. Thanks for watching.